And last but certainly not least, we have multi-step equations. Now, they're just exactly how they sound. They take multiple steps. Sometimes they can be a bit shorter than others, and sometimes they can take a little longer. So, we're going to get through this together, though. We're going to do 4 examples today. Here's our first one. 6 equals 1 minus 2n plus 5. Now, you may say that looks a little bit strange. It doesn't look kind of like the ones we've always done. Well, it's because they kind of didn't do something. Remember when we talked about combining like terms? This is where it's going to come into play. Notice I have this 1 and this 5 here. Well, they are like terms, right? So they can combine. What's 1 plus 5? Well, that'd be 6, right? So sometimes they don't like to help us out at the beginning. They like to kind of screw around with us a little bit. So we kind of simplified that down to 6. Now we solve it like we normally would. So we take away 6 from both sides. So that would be 0 over here. Now you can technically cross that out, but I like to make sure I put a 0 there. Equals 2n. How to get rid of the 2 in front of the n? You divide. So 0 divided by 2 is just 0. Boom. That's it. So notice we just kind of make it a little bit easier on the eyes, and it turns back. Most of these always turn back into the same ones we always have done before. All right, let's do another one. This one's going to make us combine like terms, but it's also going to have something a bit weird. It's going to have letters on both sides, which we haven't seen quite yet. 3p minus 8. Okay, so let's do the same thing we did last time. Notice I have a p here and a p there. Let's combine them. 5p plus 3 more p's, that's 8 p's. All right, let's drop the rest of this stuff down. This minus 8, this p minus 1, and let's go from there. Now, this is a bit weird because you have different things to do it, but what we want is we want all of our p's on one side, or our letters, whatever, and all of our numbers on the other. So let's do that. Let's move this over here and that over there. So the way I do this, just kind of like we did before, this is a positive 8p, so I need to move it over by subtracting. Now subtract from this one right here, okay? Because you want your p's together. And also you want your numbers together. So, well, all my p's are over here, but I don't want this 1 over here, so let's get rid of it by adding it. So now look, these p's went away, moved over there. This 1 went away, moved over there. So now all of our letters are on one side and all of our numbers on the other. That's the point. So this is like a 1p. Whenever there's not a number in front of something, it's always like a 1p. So 1p minus 8p, that's 7p's, negative 7p, excuse me, equals negative 8 plus 1 is negative 7. This is another strange one. How do you get rid of the negative 7 in front of the p? You divide. Now, these don't cross out and leave you with 0. A lot of people that I've always taught, they always, 0. No. When you divide something by itself, it's always going to be a 1. Two strange ones there, but nothing too odd, just kind of just a little bit weird. Now, these next ones are going to look a lot scarier than they actually are, okay? So, let's do these next two. This next one, we're going to have parentheses. And remember, the big D word we have always talked about when we do parentheses is distribute. Now, we did an example on the 2 steps where you could actually divide first, and there's nothing wrong with that, but sometimes when you have multi-step equations, especially when you have letters, whether it be A, B, C, D, or X, Y to Z, sometimes it's a bit harder to do, and I would not suggest doing it, okay? So this first one, you're going to see parentheses around something, okay? So 3n, take away 5 equals negative 8, and then 6 plus 5n. Now, I haven't been giving you a verbal description of this, but I will, because it's kind of hard to see. 3 times something minus 5 is equal to negative 8 times 6 plus 5 times something. I can't figure that out. That's why we use these steps here on multi-step equations, and really for any equation, to kind of prove that what makes this side and this side equal to each other, what makes it a true statement. So, like I told you before, I used to say, well, hey, let's divide this by negative 8. I would not suggest doing that on here, because then you have all sorts of messy fractions. So instead of doing that, let's distribute like I showed you a little while back. So negative 8 times 6 is negative 48. Negative 8 times 5 is negative 40, n. And then on this side, you have 3n minus 5. And look, remember how I talked about everything kind of turns into the very similar type of problems. And this is actually no different. So let's move over the 5 to this side. And it doesn't matter what you move over where, okay? I could have moved the 48 over here and the ends over there. I just like my ends on the left and my numbers on the right, or my letters on the left and my numbers on the right. And then let's go ahead and move this 40n over to this side. So let's add it over. So that'd be 43 n's, and then equals negative 48 plus, this is another, we're getting weird ones for this, so that's good though. Then now, how do you get rid of the 43 in front of the n? You would divide. So again, now, this is where it gets a little strange. Negative 43 divided by 43. Well, if they were just positive there, they just cancel out and give you 1, but because that negative sign there gives you a negative 1. Giving you weird ones today. Hopefully that's not too stressful for you. This one's going to be a big one. Ready for a big one? I think y'all are ready for a big one. I'm going to write this all the way over here. Negative 5 in parentheses 1 minus 5x plus 5 in parentheses negative 8x minus 2 equals negative 4x minus 8x. Big one, but the big deal is let's just combine like terms. Let's focus on what we can do, okay? I'm going to kind of do a couple steps in one. Over here, I'm going to combine the negative 4x and the minus 8x. It's negative 12x, okay? Easy enough. Now, let's go ahead and distribute all these things out and see what we get, okay? So this would be negative 5 right into here. So that's going to be negative 5 plus 25x. Because remember, what I'm doing when I'm distributing is I'm multiplying. So negative 5 times 1 is negative 5. Negative 5 times negative 5x is 25x. Let's do the same thing with this little 5 right here. 5 times negative 8x is negative 40x. Then 5 times negative 2 is negative 10. All right. Now, what else we got to do? Well, looking at the left side, now I've got like terms on the left side too. So crap, let's take care of that. 25 minus 40, that's negative 15x. And then we have negative 5 and negative 10, that's negative 15 equals negative 12x. We're almost there. Thank goodness, right? All right. Now here's a bit of a strange one. Again, I'm trying to give you intentionally weird ones here. So we want our x's on one side, our numbers on the other. What I'm going to do is a bit backwards. Remember how I always wanted my x's on the left and my numbers on the right? I'm going to do this one a bit backwards to prove that it works no matter what. So let's move this negative 15 over to the other side. So let's add it over. Plus 15x here. Let's add it over to this side where the x is at over here. Notice that always the x's are always on top of each other. So remember when I moved this over, my numbers were on top of each other, and my numbers were on top of each other, and anything with a letter was on top of each other as well. So negative 12 plus 15 is 3x, and this equals a negative 15. And then there, how do I get the 3 in front of the x? I just divide by 3. Big one there. So x is going to be equal to, I want to write this over here because I ran out of room. X is going to equal to negative 5. Notice how I wrote that. Technically speaking, the way this would be looking after you do this, it'd be like this. X equals negative 5. But either way works for me. I don't care how you write it. You can write it that way or that way. Either way is good to me. That's multi-step equations. Some of them can be small, like 3 steps. Some of them can be like this, which was a lot of steps. And if you ever need to break it down and kind of do just this part here and then work it out, that's fine. I kind of combine the steps together here just to save some room because I don't have a lot of room. So let me know if that made sense. If you had any questions, let me know. I do apologize. This down here did get cut off a little bit, but I just divided by 3. Sorry about that. So let me know if y'all need anything.